Hello students. Now I am going to explain about differential equations of higher order type 2. Type 2 is related to trigonometric functions. It may be sine or it may be a cos function under the concept advanced calculus and numerical methods. Already I told you this type 2 is related to sin x or cos x. They won't give any of the other trigonometric terms like secant, cosecant, tan, cot. So suppose they given in that form means, so we have to apply some other methods like method of variation of parameter to find out the solution of that type of differential equation. Now here I am going to explain about only the type 2. So to find out the solution of the particular integral, suppose it may be a sine or a cos, means how we have to find out the particular integral. So here RHS function, it may be a sine AX or cos AX. Then some of the formulas, some procedures we have to apply to find out the particular integral of a given differential equation. The formula will be like this: sin AX or cos AX, denominator, equation in terms of d. That equation we have to write. In that equation, where and all d square is there, we have to replace that d square as minus a square. A represents coefficient of sine or cos. In that function, the coefficient of x. So a we have to take, so minus a square. Just replace d square as minus a square. Here you have to remember, in a denominator, f dash of minus a square, f of minus a square should not be equal to 0. Suppose if f of minus a square after replace in a equation f of t, after replacing d square has minus a square, denominator should not be equal to 0. Suppose denominator is equal to 0 means, then we have to apply the ordinary rule. What is mean by this ordinary rule means, numerator we have to multiply by the independent variable. Here independent variable is x into sin ax, denominator you just do the differentiation of f of d with respect to d. So you will get f dash of d. You just replace wherever d square has there, you just replace that as minus a square. Even here also, denominator f dash of minus a square should not equal to 0. Suppose denominator is equated to 0 means, then once again we have to apply the same procedure. This is what working procedure in a type 2. Now we'll do one problem based on this type 2. Question will be like this: solve d square plus 4 into y, which is equals to sine 3x. Students, here you just observe the RHS part. Here trigonometric function sine 3x they given. So first we have to find out complementary function. So solve means we have to find out the general solution. General solution means it's a sum of the complementary function and then particular integral. So first we have to find out complementary function. So first what we have to do, we should write that auxiliary equation with the help of f of d equation. Just replace d by m and then equate it to 0. That is what our auxiliary equation. Here we are getting m square plus 4, which is equals to 0. On solving this equation, we are getting the roots of the equation as m equals to plus or minus 2i. Students, you just observe here the value of alpha is 0 and beta is 2. With the help of this, we should write the formula of complementary function. Complementary function. yc equals to c1 cos 2x plus c2 sin 2x. After getting this complementary function, next is we have to find out the particular integral. The formula of the particular integral is RHS divided by f of d. Yp equals to 1 by d square plus 4 into sine 3x. So here you just observe numerator trigonometric function sine 3x is there. Denominator d square plus 4 is there. Already I told you trigonometric function sine or cos the given means we have to replace d square by minus a square. Here square is applicable only for the term a, not for the negative sign. A represents here, the a is the coefficient of x in a trigonometric function. So that here the value of a is 3. 3 square means 9 with negative sign. So you just replace minus d square as minus a square. It means minus 9. Denominator the equation as d square plus 4. Replace d square by minus 9. So minus 9 plus 4. So we are getting solution as minus 5. So particular integral is sine 3x divided by minus 5. After getting this particular integral, next we should substitute that solution in a general function, in a general solution formula. The formula will be y equals to yc plus yp. Yc we got it as c1 cos 2x plus c2 sin 2x, and yp is minus sin 3x divided by 5. This is what our required general solution of the given differential equation. Now we'll go for solve one more problem. The previous problem is related to sine. Now the second problem is related to cos. Solve d square plus 3d plus 2 into y, which is equals to cos 2x. So first we should write the auxiliary equation by replacing d by m, so that we are getting one quadratic equation in terms of m. That is m square plus 3m plus 2, which is equals to 0. On solving this quadratic equation, we are getting the roots of m as minus 1, minus 2. Here the roots are real and different. So the roots is m equals to minus 1 and then minus 2. So complementary function will be c1 e to the power minus x plus c2 e to the power minus 2x. After getting this yc, now we have to find out particular integral. RHS is cos 2x. Denominator we should write the f of d equation, d square plus 3d plus 2, which is equals to, we should write here, you just see denominator d square is there. So we have to replace d square by minus a square. A is coefficient of x in the cos function. That is a equals to 2 minus a square. It means minus 2 square. That represents minus 4. So in a denominator, in place of d square, you just replace as minus 4. So after simplification, we can write this equation as cos 2x divided by 3d minus 2. So now after simplification, we should get one constant term in a denominator, whereas we are getting 3d minus 1. Still that d term is existing. We have to eliminate that, but we should not touch the d term. We need only the d square. So we'll go for the conjugation. 3d plus 2 divided by 3d plus 2, multiply and divided by 3d plus 2 in that equation. Numerator we have to multiply, denominator also we have to multiply. Numerator 3 into differentiation of cos 2x. After differentiation of cos, we are getting minus sin 2x into 2 plus 2 into cos 2x. Denominator 3 3s are 9, d square minus 2 2s are 4. So here d square, you just replace it as minus 4. On simplification of the denominator, we are getting solution as minus 20. So that the particular integral can be written as sine x divided sine 2x divided by 20 minus 1 by 20 cos 2x. This is what our yp. After getting particular integral, next we should substitute in the general solution formula. Y equals to yc plus yp. Here yc is c1 e to the power minus x plus c2 e to the power minus 2x plus 3 by 20 sin x minus 1 by 20 cos 2x. This is what our required general solution. This problems just I given for your practice. Y double dash minus 4y dash plus 13y, which is equals to cos x, and one more is 4 cos square x. That cos square x, you just convert that in terms of cos with the help of some formula, and then easily we can find out the solution of the given two differential equation. Thank you.